This project was for statistics, was based on physics.
Our goal was to discover if the length of the pendulum had an effect on your period.
Well, we decided to measure the period of pendulums with increasing lengths of 10 centimeters each.
Let's get started!
Hypothesis. If the length of the pendulum affects the period of the pendulum, then a constant increase in the length of the pendulum will produce a constant increase in the period.
For this experiment, we will tie 3 washers to the stream and measure the period of the following lengths: 20, 30, 40, 50, 60, 70, 80, 90, 100, and 110 centimeters. And to do this, we'll measure the time it takes for 10 oscillations and then divide by 10 to find the period.
3 washers, 1 string, 1 ruler.
The x value is the length of the pendulum, and it varies between 20 centimeters up to 110 centimeters. The y value is the period of the pendulum, and it varies from 0.95 seconds up to 2.75 seconds.
The values we used to get the correlation coefficient of our values, which was 1. This means that the relationship between the length of the pendulum and the period is a perfectly positive correlation. The correlation determinant was 1, which means that all 100% of the y values depend on the length of the pendulum, which is x.
The regression equation is y equals a plus bx, where we can insert a value in x, the independent variable, to find out y, the dependent variable. In this experiment, the regression equation was y equals 0.55 plus 0.02x. So for every centimeter we add to the length of the pendulum, the period increases by 0.02 seconds. And when nothing is added to the length of the pendulum, the period is 0.55 seconds.
In this scatter plot, the blue points are the measurements we got in the experiment, and the orange points are y prime, which we got based on the regression equation. The blue points and orange points are almost the same, proving that the experiment was accurate and the length and period of a pendulum have a perfect positive correlation.
If the length of the pendulum is 200 centimeters, then the period will be 4.55 seconds. If it's 300 centimeters, then it will be 6.55. And if it's 400 centimeters, then it will be 8.55 seconds. All these inferences show a constant pattern and demonstrate that the period depends on the length, since every time it increases by 100 centimeters, it increases by 2 seconds exactly.
We not only learned about length and period of a pendulum, but we also learned and applied several of the habits of mind, such as thinking and communicating with our classmates with clarity as well as striving accuracy.